Good morning, everyone. Welcome to the class Precision Measurements and Control System. Today, I will continue on some new things, but now let's have a revision. The homework will be submitted early. The homework will be submitted a little early, Tuesday each week, and I need to check out how you have done before the class. Okay.
Okay, launch.
So
Okay,
we change to the Tuesday each week.
Okay, launch.
Submit a little early. I need to check out how you have done before the class. Okay. This is the assignment of the last class. The first one is try to use pin 12 to break the LED. Second is try to set the break rates at twice a second. Some students told me that connecting the P30 the pin 13 works, but connecting the pin 12 does not. You can see here as the picture that connecting P30 works, but connecting P12 does not work.
Yes, launch.
This is because use writing. Usually is not because usually is not consistent with the code, with the simulation codes. So we need to change. So we need to change to P30 to 12 in the code. Let's do the 4 assignments together again. Okay.
Okay, launch.
Okay, design and choose the showcase new circuits. Okay, the first Add Arduino or no, and drag a breadboard small. Then we add a LED. Add a resistor. Okay. And okay. Okay. Connect the power. Connect the ground and or color. Okay, let's start simulation. We can see it doesn't work. Okay. When we collect the pay 30, it doesn't work. No. Okay, we can see when I collect the page 12, the page 30, the light is breaking. That is breaking. Okay. But when I connect the A12, let's A12, let's start simulation. That's okay. We can see the lights that doesn't work. Okay. Because we changed the pin in the circuit, but we didn't change the codes. The LED part let's start simulation. Okay. No.
Laushi, it will be 12.
Oh. We can see when the code is something wrong, it's in the serial monitor, where you can see monitor will show you what's some errors. You can see the errors is expected on the read file before number consistent. Okay. LED. Okay. Oh, we are here. LED button stands the pin model. Okay, LED. Yeah.
Laushi, I also faced the same problem. You can use only LED in place of LED
Oh,
built.
yes, you're right. Good. Yes, LED. Now the button. Okay, we can see light is breaking also. Okay, we connect the 12. You can see our segments is try to use A12 to break the LED. We can see in the figure the pin we connect the P so T. Oh, yeah. Correct. So some students do it according to the figure. So when the connect 12 P12 simulation it doesn't work. So we need to change the LED to be consistent with the pin model. Okay, with the pin model, you can see the LED is changed to 12. And we connect to 12. Okay, here to 12. And then let's change the black rate to 15. Okay, let's start simulation. Okay, we can see black rate. The breaking rate is 4 trace seconds. Okay. Breaking rate is fast than 4. Okay. So we should remember use really is consistent with the codes. Okay, with the code. The wiring should be consistent with the codes. The LED number should with the pin model should be consistent. You can see let's change the delay time again. Relation. The delay time is so short, so we can't see Korean. Okay. Okay, break rate is trace seconds. Okay, is a segment of the last class. Some students have any question?
No, Laushi.
No logic.
Okay. Okay, let's run some new things. Let's some new things. The first content today. The first part is project one. Go to long use tools. The second part, project two, is space shape interface. Project one, go to no use tools. In this project, you will become familiar with the toolbox that comes with Arduino basic kit. The concepts covered include basic breadboard skills and switches in series and parallel and Ohm's law. We will look at the common tools in projects from these three aspects. First, the getting started with electricity. First, the second part is build a circuit. Three parts introduce to Ohm's law. Okay, let's continue. Why we use electricity? Why we use electricity? Electricity is a type of energy, much like heat, gravity, or light. Electrical energy flows through conductive materials like metal wire. You can convert electrical energy into other forms of energy to do something interesting, like turn on a lights or make some noise with a speaker. So the components you may use to do this, like speakers or light bulbs, are electrical transducers. Transducers turn electrical energy into other types of energy, like heat and lights, and vice versa. Since that converts other forms of energy into electrical energy are often called sensors. We all know sensors. And since that converts electrical energy into other forms of energy are sometimes called actuators. Sensors, actuators. As you can probably imagine, we use electricity in almost every aspect of our lives. We can see in the picture, the light bulb is an electricity transducer that converts electrical energy into heat and light. Okay, let's simulating the circuit in the workplace. Let's simulate the circuit in the workplace. First, we should to check the name wallet poll. First, select the name wallet poll. Then add a button. We need a register. And need a light bulb. Light bulb. Okay, we need a light bulb. Okay, we can press the button. I need to turn the adjust the resistance direction. Okay. Let's connect the button. Let's connect the wall. Okay. The resistance change to the 220. Then simulate, we can see the circuit is completed. Now we simulated the circuit by start simulation. We can see when I connect on the button, we turn on the lights. Okay, click on the button to turn on the lights. We can see that when we connect the button, the circuit connect the light bulb and connects, the circuit connects and the light bulb lights up. And Okay. We can see the picture. This circuit it contains a now orange button, now orange button, push button, as resistors or light boards. Okay, a very simple circuits. You can see. Select the button. Breadboard is head up. Okay. Give you 5 minutes. You can try simulate the circuit in use workplay. Okay. Give you 5 minutes. You can
Yes,
try
Laoshi.
simulate the circuit in the workplay, in use workplay.
Laoshi, I have done it.
Okay.
Actually, what's the voltage of the resistor? I mean the capacity of
What?
the resistor.
Register.
Resistor. Yeah.
It's 220.
120.
120.
Yeah.
We set the resistance to 120. Okay. If anyone has finished the simulation, you can share your screen and show us your simulation.
Laoshi, I want to share.
Okay. Okay. Now you can. Okay. You can share your screen.
Laoshi, can you see it?
Oh. Okay. You can use computer share your screen.
Laoshi, can you see it?
Yeah. Okay.
Yes, Laoshi, it's working, Laoshi.
Okay. Okay. Good. Good job. Yes. Right. Wait a minute. What's your name?
老师 6-4.
6-4. Let me because use the student ID.
Lashi, please, can you show the circuit again? Lashi,
Mm-hmm.
please, can you show the circuit? Some of us are still doing.
Okay. Wait a minute.
老师 64 log
Your student's
64
number
64
is what? What is
老师 64 log
6-4?
yes老师 this one yes老师.
Okay, good. Okay, good. Any other students want to share use simulation?
Yeah, Laoshi.
Mm-hmm.
Laoshi, I have done the work, but my bulb is not blinking. I can show you.
Okay. Now you can show your screen.
Wait. You can see my screen.
Okay.
Everything is done. Here it's 2 to 0. Still, the LED is not blinking. You can see.
Yeah.
Yeah, so I don't
Let's
know what is the
see.
problem.
You can try so let's use push button. Okay. Maybe the
Or I can do it again if you want. Let's do it again.
yeah.
You see, Laoshi, still not working.
You
Lastly,
connect the
the
part.
unit of the resistance will be 220 ohm. It's not kilo ohm.
Ohm.
Oh,
Yes,
okay,
good.
it's working.
Okay. Good.
Now she
Okay,
can I
I'm
share my
stopping
screen?
my share.
Okay.
Now she can I share my screen? Please, can you see the screen?
Okay. You connect the button.
Yeah, I have.
Okay, good.
Stop the share now.
Okay. Good job. Any other students want to show you simulation?
Yes, sir. Can I share my screen?
Yeah.
Fucking internet.
Okay. Any other students?
Oh, shit, your camera.
Okay.
I want to show my
Okay. Well, some students just show the simulation. Give me use student number. Let me record it.
Yeah, it's 7-7, Loshe.
5.
7. Okay.
7-7, not 0, not 0-7.
7.
Go down, Loshe. Down.
Which
Yeah,
one?
7-7.
Oh,
7-7.
713.
Number 36.
36.
Okay, Concilio.
36. Well,
Oh, no, I'm sorry. Then 7-7, you can see the number.
Oh, she down. Down again. Down 2 more. Yeah, that one. 7. No. Yeah, and that 7. Yeah, that one. No,
oh,
that's 7-6. The next one. Yeah.
yeah, good.
And last 55. Wushu.
55.
Yeah.
This.
Okay.
Oh, this one. Yeah.
Lausche and 59 Lausche.
59. Any other students?
Laushi, I want to show my screen.
28, Laushi, 28.
Okay.
9 Laushi, the last one.
I'm here. I'm not sharing the screen.
Okay.
9.
Maybe I should.
Laushi, can you see?
Okay, not the one. Okay, not the one.
Master,
Can you see?
98, yeah.
Hello, Laushi. Hello, Laushi, can you see my screen?
Okay. Good. Okay.
My student ID is 03.
02. Okay.
033. Sun.
Okay.
Uh,
Let's have a break. After
she
10
wanted to
minutes.
share the screen.
Come back. Okay.
Uh,
Okay. Have a break.
Okay,
Okay, Laushi.
Hello, everybody.
Yes, Laushi.
Hello, Laushi.
Let's continue.
Yes,
Okay.
Laushi.
Alright.
Yes, yes.
Hello, Laushi.
Okay.
Laushi, can I please share my screen, please, Laushi?
I can't hear you. What?
Can I share my screen? Hmm?
After class, okay.
Okay, Laushi. Okay, thank you.
Okay. Maybe you can send me a video, okay? Getting start with the electricity. Let me introduce the circuits. Circuits are closed loop of where with a power source like a battery, and components to do something useful with the energy, could or load. In a circuit, electricity flows from a port of high potential energy, usually referred to as a power plus to a port of a lower potential energy. Ground of presented with present or ground is the ports where potential energy is lowest in the circuit. In the circuit, you are building electricity only flows in one direction. In this circuit, you are building electricity only flows in one direction. You can see one direction. This type of circuit is called direct connect or DC. Direct connect. Let's get familiar with the terms voltage, connect, and resistance. Connect measured in amperes or amperes with the symbol, with the A symbol, is the amount of electricity charge flowing through a specified point in the circuit. Voltage measured in volts with the V symbol is the difference in energy across one point in a circuit and another. Resistance measured in ohms with the O symbols is how much a component impedes the flow of electricity energy. A few things about circuit. First, there needs to be a complete path from the energy source power to the points of last energy ground to make a circuit. If there is no path for the energy to travel, the circuit won't work. The flow of connect at specified points in a circuit will always be same coming in and go out. Some coming in, go out. In the picture, connect in the picture connects at 1 and 1. You can see, and 1 is equal to the connect at 2 plus the connect at 3 and is equal to the connect at 4. You can see in the picture. Connect at 1 is equal to the connect at 2 plus connect at 3 and is equal to the at connect at 4. Notice electron connect will seek the path of lattice resistance to ground. Electron connect will seek the path of lattice resistance to ground. If two possible paths, more of the electron connect will go down the path with less resistance. So if you have a connection that connects power and ground together with no distance, you will create a short circuit, not circuit. And the connector will try to follow that path. In a short circuit, power source and wires convert the electrical energy into light and heat. Usually as sparks or expression. If you have short button and since sparks, you know how dangerous a short circuit can be. If you have short a button and see sparks, you know how dangerous a short circuit can be. We can see the picture. Is a breadboard. The breadboard enables you to collect proper type circuits quickly without having to slow the connection. The 5 Hz is array. This zone. The 5 hotels in each hotelator are connected electrically through metal chips inside the board. Okay. The 5 hotels in each horizontal row are connected electrically through metal chips inside the board. And the vertical traps that turn the length of the blackboard are electrically connected. The chips are usually used for power and ground connections. You can say power. And the middle row breaks the connection between the two sides of the board. You can see the middle row breaks the connection between two sides of the board. Power bus. This is a protractor pin array, okay? LEDs are polygonal components, which means that only electricity to flow through them in one direction. The longer leg on the LED is called a node. It will connect to the pole. The short neck is called the short neck is cathode. And will connect to the ground. The longer leg is called a node. It will connect to the pole. And the short leg is cathode and connect to the ground. When voltage is applied in the proper direction, the LED emits light. We can see the LED contains its poreless gas, wire-board, reflective covet, semiconductor stack, laser flame, and flash spots. Resistance. A resistor is a component that impedes the flow of electrical energy. Without the resistor, the LED would be brighter for a few moments, but quickly burn out. In the simulator, this burnout is represented as start bursts of the LED components. The resistor affects the light bulb as well. I change the value of the resistor in the workplace by highlighting it and use the drop menu. Okay, let's see what each value does to the brightness of the bulb when you push the button. We can see two pictures. The left picture with the resistor, right picture without resistor. Without resistor, too much energy will burn out the LED. Notice the start burst over the LED. Okay, let's simulate burst situations in the simulator. Let's simulate burst situations in the workplace. Okay, first select either Arduino or no. Breadboard. First, let me read the register. Okay. Just connect the power source. Connect the ground. Okay. Okay. Oh. The first situation with a resistor. Let's start simulation. Okay. We can see the LED is light up. The LED is light up. In the first situation with the resistor. Okay, let's simulate the second situation. Let's connect the start simulation. We can see the LED burns because too much energy burns out the LED. Simulation. Okay. In the second situation without a resistor, too much energy will burn out the LED. because resistor converts some of electrical energy into hertz. If you put a resistor in series with a components like a LED, the resistor will use up some of electric energy, and LED will receive less energy as a result.
Yes.
Okay, let me stop simulation. So too much energy will burn out the LED. So the resistor will use up some of electric energy, and the LED will receive less energy as a result. This allows you to separate components with only the amount of energy that they need. You use a resistor in series with the LED to keep it from receiving too much connects. The value of strength or resistance is indicated by the colored. You can see the value of a strength and the resistance is indicated by the colored bonds on its boards. Resistor color codes are covered in the forum in the next contents. Color strips. We can see resistors includes in these strap kits. You fed either F4 band or F5 band with them. Resistor values are marked use the colored band according to the dual color developers in the 1920s, when it was too difficult to write numbers such in objects. Each of the 4 or 5 colored bands corresponds to our number, like you see in the table. In the 4, you can see in the 4 band table, the first 2 bands indicate the first 2 digits of the value, where the third one indicates the number of zeros that follow. Generally, it spans a power of 10. A power of 10. The last brand specifies the tolerance. In the example 4. Gold indicates that the resistor value can be 10 kilo ohms plus or minus 5%. You can see can be 10 kilo ohms plus or plus 5%. Push button. A push button or switch forms of connection in a electrical circuit when it's is activated or closed. When the button is not activated or is open, activate or open or it's open, it interrupts the flow of electricity, breaking the circuit. It interrupts the flow of electricity, breaking the circuit. Switch connections. There are two pins. The two pins of a switch are connected to each other. The two pins of a switch are connected to each other. These two are nuts that form the switch. Okay. These two pins of switch are connected to each other. And these two are nuts that form the switch. Okay, next let's build a circuit. Let's build a circuit according to the circuit schematic. Okay, let's build a circuit according to the circuit schematic. First step is connecting power. Okay, Arduino connect the power. The first step is connecting power. Then you need to add the LED and the button. Next is add the resistor and the walls. Once the circuit is complete, you can try simulate it. Okay, once the circuit is complete, you can try simulating it. Okay, let's simulate. Okay, let me simulate the circuit. Okay. First, let me add a push button, then add a LED. Add a resistor. Connect wall. Change the color. Okay, let's start simulation. So when I click the button, LED is lighting up. Okay. When I click the push button, LED lights up. Okay, let's continue. Stop the simulation. When you finish the simulation, now you can try out to use a simple button circuit with Arduino kits, with Arduino physical kits. Start by plugging your Arduino board into your USB ports on your computer. Plug in your Arduino. Then try pressing the button. When you press the button, you should see the LED light up. So when you press button, you will see the LED light up. Okay, let's continue. Build a series circuit. Once you have tired of pressing the button to turn the light on, it's time to shake things up by adding a second button. Can add a second button. So we connect the button in series. So we will connect the buttons in series. Components in series come one after the other. They share a connection at one terminal. Check out the circuit diagram. Showing the button in series. The components have the same You can see the components have the same electricity connects flowing through them, and the bursts have to be pressed. In order to complete the circuit to turn on the LED. Okay. The components have the same electricity connects flowing through them, and the bursts have to be pressed in order to complete the circuit to turn the LED. Okay. Let's simulate. Let's build the series circuits in the workplace. Let's build a series. Okay, let's put in another button into the work plane. Bring another button to the work plane. Okay. I run arrange energy and reconnect them in series as shows picture. Okay. Run ledger and reconnect them in series. Okay, let's connect the simulation. When I connect the button, it didn't work. The LED doesn't light up. Okay. Okay. Let's see when I start simulation. Connect the button. One button, the LED. Doesn't light up. Okay, so we need press both buttons.
Is it like you have to click together, Laoshi?
Yeah, so we need press both button. Press both button in the simulator requires a special method. You should hold down the shift key. Hold down the shift key and press each of the button. You should hold down the shift key and press each other. Holding the shift key, turn the switch into a latching switch that stays closed after you have pressed it. Okay, let me hold down the shift key and press each other. You can see the lights, but the LED lights up. LED lights up.
Yeah.
Okay. Notice you need to locate holding the shift key, turn the switch into latch switch. Latching switch that stay closing after you have pressed it. So when we need to press first push button, we should hold down the shift key. Okay. Good. We was 9 points. Okay. Okay. I forgot to impact message last class. Our class is whole morning divided into 2 parts. The first part is first half of the class is 8 o'clock to 9:14. The second half of the class 10:10 to
Yes, sir.
11:50. Okay.
Okay, Laushi.
Okay. Let's have a break
Okay,
after
Laushi.
30 minutes.
Laushi.
Okay.
Yeah, I was about to show you that class works earlier. So can I show you? Just look at my screen. I have opened the camera. You can check the camera.
Okay. Let's have a break. Other students, you can have a break. Okay. You share me video. Okay.
Yeah. Laushi, can you see?
Okay. Wait a minute. Okay, other students, you can take a break and go back in 30 minutes. Okay.
Laushi.
Okay,
Yeah.
Laushi.
Did you saw?
Yeah, I can see your screen.
And the bulb is glowing now.
You connect the button.
Yes, Lausi.
Okay. Yes, yes.
Yes.
Laushi, please, can you check your inbox?
Okay.
Lausi,
Laushi,
my number is 57.
You can send your student number to the chat window. Okay.
Where, Lausi? Where? Where to send?
Laushi,
Okay. So
did you check?
Okay. No, I can hear you.
I say, can you please check your inbox?
Mm-hmm.
Yes. Did you see?
No.
How no, Laushi? On
You didn't share your screen.
no, I just sent mine. You told me to send mine.
Okay. Okay.
You saw it, right?
Yes. Okay. Okay, let's have a break and then go back after 30 minutes.
Okay, Laushi.
Okay.
দেবো না সত্যি সত্যি কি দিবি এরে বলছি মানে একটা শেষ
Okay. Are you come back?
Yes, Laushi.
Okay.
Yes,
Let's
Laushi.
continue. Okay, let's continue the class. We built a series circuits. Next, let's build a parallel circuit. Yeah. Now that you have mastered the art of button in series, it's time to bring up switches in parallel. Commanders in parallel are placed side by side. The share connection at the two terminals. The share connection at the two terminals. Check out the circuit diagram showing the button. You can see showing the buttons in parallel. Either button can be placed in order to create a continuous circuit path that turns on the LED. Okay, let's simulate the parallel circuit in the workplace. Let's start by selecting the connection between two buttons. Let's connect the left button terminal to each other. connect the right button terminals to each other. Now the buttons are connected in parallel. Buttons are connected in parallel. Simulate the circuit. Okay. Because the two buttons are in pair in this time. When you press each button individually, the LED will turn on. You can see, press the left button. The LED lights up. Select the light button. LED turn on. So when you press each button individually, the LED will turn on. And this means that the electrical connect is slipped between them. Okay. So the power has stopped simulation. So the power circuit is built like this in this picture. Because this button and these two buttons are in pair in this time. When I press either button, individually the LED will turn on. Okay, that means the electricity, you can see, that means the electricity connects between them. Is slipped between them. Okay. Next, let's learn a fundamental. Let's learn a fundamental law of electricity. The Ohm's law. Ohm's law. When you change one of these circuits, it affects the others. When you change other, voltage connect resistance. When you change one of these in a circuit, it affects the others. The relation between them is known as Ohm's law, named for George Sam Ohm, who discovered it. Okay, when you change one of these jets in a circuit, it affects the others. The relationship between them is known as Ohm's law. You can see the voltage is equal to connect time connect time. Voltage is equal to connect times resistance. And we can see the three figures. First one, voltage is equal to connect times retain connect times resistance. And the second figure, connect is equal to voltage divided by resistance. And the last figure, the resistance is equal to the voltage divided by connect. So when you change one of the inner circuits, it affects the others. Okay. Multimeter. A multimeter is a useful tool for that can multiply the amount of resistance of a component and the voltage across a component or the amount of connects running through user circuits. When the simulation is running, change the value of the resistance by handling it. The brightness of the LED will change. Okay, let's make the simulation in the workplace. Okay, use the multimeter to let's make the multimeter to modify the connect. Okay, let's delete the errors. Search the multimeter. Okay. We can search the components, choose the all. Okay. Basic all. Okay.
First it will say MULTI
Let's connect.
老师
Use. I can't hear you. Use voice. It can turn.
Yeah, I'm saying like how you searched it, MULTI or MUITI.
What? Use
This
the voice is
component,
too low.
yeah, this yellow component, how you searched it, MULTI or
Search the we choose our component and search. Input the multimeter. We will choose. We display and we judge out. Okay.
oh multimeter. Okay.
Here are search window. Okay. Search window. Let's connect the. Oh. Okay, let's start simulation. We can see the voltage is 3 points. 3 points. So 16.6. Okay. We can change the resistance. Use the drop-down manner. You can try a range from 100 ohms to 100 kilo ohms. Okay. Okay. Stop simulation. You can start it. Done. Yeah. You can try a range from 1 ohms to 100 ohms to 100 kilo ohms. See, so, okay. Let's when we choose the amperes, okay, it will display the connect, and when we choose the voltage, it will display the voltage. See, choose the amperes. Okay. We can change the resistance from 100 ohms to 100 kilo ohms. How does the brightness of LED change with amount connect flow through it? You see. When I set the 100 ohms, you can see the LED. When see the 500 ohms, can do change. We can see. Okay, let me. Okay. When the resistance sets 100 kilo ohms, you can see the LED turn. You can see LED, the brightness is very, very low. Okay. And how low of a resistance value can you set before the LED burn out? Let's see. We can see when the resistance is too low, the LED bursts out. At this port, the measurement will tell you the measurement connect that the LED can hold. So at this port, the measurement will tell you the maximum connect that the LED can hold. Okay. One change to 100 ohms. It can work normally. Okay. One change reduce to 5 ohms. It also can work. When reduced to 10 ohms, the LED bursts out. Okay. So the connect that the LED cannot hold. So the multimeter will tell you the max connects that the LED can hold. Okay. Okay, let's stop simulate. Okay, let's continue. Measure. How much connect is running through the circuit? Let me see the let's see the figure. Anybody can tell me how much the collect is in the circuit? The separate is 5 voltage. Anybody can tell me how much the circuit is in the circuit?
Lastly, it will be 0 point something.
What? How much?
0 point something.
0, 1. Okay. One performing almost low connections. You can.
Oh no.
Okay. You can apply the you can apply the
Okay.
Ohm's law.
Lastly, it is 0.013.
Okay. Operator. Yes. When performing almost low collection, you can apply the section to individual components. Referring to the circuit diagram, the 5 supports, we can see the 5 separated by the battery. By the battery is shared by the LED. It's shared by the LED and the resistance. And the LED use the LED use 2 voltage. LED use 2 voltage. So there is a 3 voltage dropped left over the resistor. Okay. The LED use the 2 voltages. So there is a 3 voltage you drop left over the resistor. So you should have 3. So you should have 3 equal to the I plus 220. You'll find that is I is equal to 2.2136. About 12.5 thousandths of the amperes. Okay. Okay. Three. I.
Into 220.
Yeah. So 2 8
ampere.
voltage 3 is equal to the connect I plus the resistor 220. Okay. So the connect I is about 12 pro, 34.5 thousandths of ampere. The 13.5 milliampere is a self-collect value for this LED, which is why we always use the 20 and we use 220 ohms resistor to protect LEDs in the Arduino projects. Okay, which is why we always use the 220 ohms resistor to protect LEDs in the Arduino project. Now, let's look at Kelhoff's first law. Kelhoff's first law. The KCF, the Kelhoff's first law. Total collect or charge entering a junction or node is generally equal to the charge leaving the node, as it has no other place to go expect to live, as no charge is lost with the node. The parameters in the figure. Okay, the left figure. You can see the parameters in the figure have a relation as shown by the formula. You can see the six parameters in the figure. Figure have a relation as showed by this formula. We can see connect flow income 3 connect flow income lane 1 lane 2 and 3 the junction across the junction node first junction connect flow outgoing out 1 out 2 out 3. Let's see inputs 1 plus a 1 input 2 plus input 3. Put parentheses, put the parentheses in the plus out 1 plus out 2 and plus out 3. Put parentheses and is equal to 0. And the KVL, the KVL Kelhoff first rule, in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops with the same loop. You can see in the figure. Voltage dA with the battery. The resistor 1 will be, the resistor 2 will be C, the resistor with C, resistor 3 with D. We can see the voltage AB plus voltage BC and the plus voltage CD and the plus voltage DA is equal to the 0. So the total voltage around the loop is equal to the sum of the voltage drop within the same loop. Okay. Voltage dividers. Voltage dividers that we use is simply two resistors in series between high and low voltage ports. The resistors share the total voltage, and you can create a custom voltage row between the two resistors by changing the value. Okay. Voltage 1, the resistor 1 is voltage V. The resistor 2 is voltage V2, and the voltage out is equal to V2. Okay, you can see relation. The voltage out is equal to V2 and equal to the 5. Okay, you can see 5 times resistance 2, and the divides resistance 1 plus resistance 2. Okay. Voltage dividers are used in many projects with analog sensors. Light sensor, for example, change is resistor when light is shining on it. Under low light conditions, the sensor is 180 kiloohms. On the bright light, it's 506 ohms. Instead of selecting resistance, selects the Arduino. The Arduino needs to sense a voltage. Okay, the Arduino needs to sense a voltage. We use the voltage divider to convert the resistor into a outputs voltage single. You can see the R, the resistance sensor, is 1,000 ohms. And the resistance 2 is 10 kilo ohms. Okay, so we can calculate the voltage output is 4.5 voltage. Okay. Okay, let's see our physical case experiment.
Laushi, there is no sound.
Okay.
Our Arduino board at all.
Yeah,
And
now
it's
it's okay.
understand all,
Okay.
Yeah, it's okay now.
start learning the basics of all the components we're going to use in the
Okay.
rest of the videos. So what we see here is a set of electronic components, and today we're going to build a very basic circuit.
We need to go.
Hi, my name is Massimo
Okay.
Banzi, and I'm one of the co-founders of Arduino. Welcome to this series of video about the Arduino starter kit. In this particular video, we're going to start learning the basics of all the components we're going to use in the rest of the videos. So what we see here is a set of electronic components, and today we're going to build a very basic circuit. We're going to use a small LED connected to a button, and when you press the button, the LED comes on. It's a very simple electronic circuit that doesn't involve our Arduino board at all, and it's designed for you to understand all the basic elements that make an electronic circuit. So what is an LED? The LED is a small source of light. You can imagine it's like a light bulb, but it's more efficient because it doesn't generate that much heat, because it's an electronic component based on a semiconductor. So LEDs are very convenient for us because they work at a small voltage. So they can be powered by a small battery or the voltage that you can get from an Arduino board. So what is a circuit? A circuit is a series of electronic components like this LED or this button connected together using wires. Electricity can flow through the components, and each component is either able to transform the electricity into something else, like light, like the LED does, or, for example, the switch is a component that can open and close a circuit when you press on it. This particular button that I have in my hand, it keeps the circuit closed until I press the button, and then it closes the circuit. Closing the circuit is like a little bit like when you open a tap. You let the electricity flow through the button. Electricity, you can imagine, is like water, and the wires that we are using to make the connections are like pipes. So the source of electricity is essentially the equivalent of something that pushes water into the pipes. So the first circuit that we're going to build is going to have a source of electricity pushing the current through the wires, a number of wires that connect to the button. Then the button will open and close the circuit, and when the circuit is closed, the current will flow through the LED. And then we will use another component that I have here called resistor. What happens is that the voltage of our battery is too high for the LED that we are using. Just to give you an idea, we're going to be using a source of electricity operating at 5 volts, which is the standard voltage at which the Arduino board operates. But this LED is only going to need about 1.7 volts. So how do we make sure that the LED doesn't take too much current? Well, we're going to use a resistor, and this resistor is going to limit the amount of current that flows through the LED, keeping it at the optimum amount of voltage and current. How do we make the connection? Well, actually, what happens with circuits is that you can take wires and you can wrap them around and you can create circuits like that, but it's not very practical. If you want to do a lot of experimentation, if you want to move components around, if you want to try different kinds of circuits, wrapping wires around is not exactly the best idea. So what we're going to do, we're going to use this component that you see here. It's called a breadboard. The breadboard essentially provides a set of pre-arranged connections, and each one of these holes is actually connected underneath with a metallic spring. So when I plug a wire into the breadboard, the spring will hold on to the wire and it will connect to all the other holes in the same line of holes. So let's have a look. For example, this line of holes that I am pointing to at the moment, they are all connected together. So if I plug this wire in this hole, all the holes in the same column are going to be connected to this wire. So if I take, for example, this resistor, and I plug the resistor in one hole in the same line, for example, here, this is okay. So at the moment, the resistor and the wire are connected together. If I move this wire to the hole next to it, they are not connected anymore because only the wires in the same column are connected together. So to explain this concept better, I have prepared here a circuit that contains a lot of all the basic elements that I told you about. This is the resistor, this is the push button, this is the LED, and this is a wire. So what's missing here is the source of power. What a circuit needs in order to operate is a source of electricity. In this case, we're going to use the Arduino board as a source of electricity. The Arduino board can be powered through a battery or through a USB connection, as you can see in this particular situation. We're not going to use the intelligence provided by the Arduino board. We're just going to use the power that you can take from the Arduino board in order to learn how to build the circuit on the breadboard. So we're going to connect this wire to the other leg of the resistor. You will notice that actually the holes on this side of the breadboard, they have a different pattern. So why is this? Because actually these two lines of holes, they follow a different connection pattern. So the ones that cover the main area of the breadboard, as I said, are all connected along the column, while these lines are going all the way from one end to the other. So these are two separate strips of holes, and each one of them is connected together. So for example, if I plug this red wire at the beginning of this line of holes, I'm actually connecting 5 volts to every single hole that you can see on this line here. So this means that the resistor is now connected to this hole. Now I'm going to take this black wire and I'm going to plug it in one of these two holes that are marked G and D. G and D is the ground. It also represents the minus on your battery. If you look at the battery, normally there's a plus and a minus. So 5V represents the plus on this ideal battery, and the minus is here represented by G and D. So if I connect the black wire to the other line on the breadboard, Now I have connected 5 volts to the first lines of holes and the black wire to the second line of holes. Now, if everything is done correctly, if I press the button, I'm going to connect the resistor to the LED. This will complete the circuit and the LED will light up. Wow, okay, it's working. Okay, that was good. So the ability to convert electricity into another physical phenomena that we can actually experience in the real world makes the LED a transducer. So the transducer is a component which is able to convert electricity into something else, or, for example, if there were a component that would convert light back into electricity, that would also be a transducer. In particular, we call the LED in this particular situation an actuator because it takes electricity and then turns into something that I can actually see in the real world. In this case, I can see the light. Electricity is invisible to me, but the LED makes electricity visible by turning it into light. We have our completed circuit, and I would like to make some modifications now to introduce some other concepts. So what we are looking at here is a very simple circuit where each component is connected to the next component in the circuit, and then the last connection goes back to GND. So you can imagine the current flows from the red wire into the circuit, through the resistor, through the push button, then in this wire, then through this LED, another wire back to ground. So this is how the circuit is closed. One of the features of this circuit is that the elements, we say, are connected in series because one component comes after the other. And we can make this circuit a little bit more complicated because at the moment we have only one button. So what happens if I connect another button? So I can remove this jumper, and then I'm going to add another push button, making sure that it's connected with the LED. So now when I press these buttons, nothing happened because the circuit is still open. We have to close the circuit using one of these wires. So I will plug the wire here. I will plug the other wire here. And if everything works out, I press the button and still nothing happens. Why? Because these two buttons are connected in series, so they are one after the other. If I want to operate the circuit, I need to press both buttons at the same time. So look at this. When I press button number 1 and button number 2, the current is able to flow through the circuit, and when I release one of the buttons, the circuit is open and it stops operating. So what we have learned now is that if we put buttons in series, so one after the other, I need to press all of them in order to close the circuit and make this electricity flow. Inside the push button, there are two pieces of metal that are separated by a spring. When you press the button, these two pieces of metal, they come in contact and they create an electrical connection and the electricity can flow through them. When you release the button, the spring pushes the two pieces of metal away and it interrupts the circuit, it opens the circuit. So you will notice that the push button has got 4 legs. At the moment we used only 2. What are the other 2 legs doing? Well, actually, they are internally connected to the first set of legs. So the 2 legs on this side of the push button are internally connected together, and the 2 legs on this side of the push button are internally connected together. So this increases the number of combinations that you can use when you create circuits. And so what happens is that if I take this jumper that I used to build this circuit, I can actually mount it behind the push buttons, and the circuit still works. So what you will notice is that this point in the circuit and this point in the circuit are exactly the same. And here, this point and this point are exactly the same. So when I press the button, these 2 points in the circuit are connected with these 2 points in the circuit. When I release the button, only these 2 points are connected and these 2 points are connected individually, but there's no connection between the 4 of them. So this allows me to try to create another connection that we call parallel connection. The idea is that we can actually place one button next to the other, and we can create two different paths that the current can use to actually flow through. Let's see what happens if we put these two push buttons in parallel. So what I'm going to do, I'm going to use two jumpers. So I'm going to connect one leg of the first push button with the same leg on the second push button, and I'm going to do the same for the remaining contact, 1 and 2. So what happens here is that if I press the button, now the LED comes on. And if I press the other button, the other LED comes on. And if I press both of them, the LED comes on at the same time. So what's happening here is that by creating two different paths for the current to flow through, I just need to press one of the two buttons for the current to reach the LED and light up. If you put the buttons in series, you need to press one button and the other button in order to create light. And in this particular configuration, you need to press one button or the other button in order to turn on the LED. So in a way, this small circuit is creating a very basic logic circuit. One that has an AND logic. You need to press one button and the other in order to light up the LED. And the second one is an OR circuit. You press one button or the other. That's all for today. I hope you enjoyed the tutorial, and remember.
Okay, let's take a rest. Okay, let's have a break. Okay. Okay. Okay, guys, let's continue. Okay.
Okay, Laoshi.
Okay.
Laoshi, I have done the assignment.
The segments. The
Yeah,
first
Laoshi, I have finished it.
to finish it. The first segment, okay, is try to build the series and the parallel circuits, series circuit and the parallel circuit. And the second segment try to add another push button in the series parallel circuit.
Yes, Laoshi, I have done it.
The third segment is try to build the circuit below and use the multimeter to measure the voltage at the points resistor 2 and the resistor 4. Okay. The series and the parallel circuits, I have take about it before the class. Okay. The segments try to add another push button in the series and the parallel circuit. If you have any question, you can ask me, okay? Let's continue the next part, project 2, spaceship interface. Correction. In this project, use Arduino is going to start in your science fiction mode. Now that you understand the basics of electronics, it's time to start controlling things with the Arduino. In this project, a control panel lights up when you press a button. These projects use digital inputs and output, variables, and basic Arduino code. We will learn about the project 2, spaceship interface, from the 4 aspects: induction, setting up the circuit, writing the code, physical quiz experiment. In this project, you will be building a control panel with the colored lights that turn on and blinking when you press the button. You can decide whether the lights mean in edge hyperdrive or 5 the lusters. You'll be using the Arduino to control the communication between inputs and outputs. A green LED will be on until you press a button. When the Arduino gets a signal from the button, the green lights will turn off and 2 other red lights will start blinking. Take a look at the circuit diagram below. When the button is not pressed, the voltage at digital pin 2 is pulled down to ground. When it's pressed, pin 2 65 voltage. Reading the voltage on pin 2 is how you will determine whether or not the button is pressed. the three LEDs are connected to digital pins. You can see digital pins, which will act as output pins. Pins 3, 4, and 5. You will need some electrical components for this project, such as push button, red LEDs, green LED, and 220 ohms resistor, and it's 10 kilo ohms resistance. And of course, use the Arduino board and breadboard. If you have a physical case and building the project at use desk, you will also need the pre-cut paper space. If you have a physical kit and building the project at your desk, you will also need the pre-cut paper space shape dashboard that comes with your kit. This Arduino's digital pins only has 2 possible states when there is voltage on input pin and when there is not. This kind of input is normally called digital. These states are commonly referred to as high and low. High is the same as saying there is voltage here. And low means that there is no voltage on this pin. When you turn on output pin, I use a command called digital writer. You turn it on. Voltage between the pin and the ground will measure 5 voltage. When you measure 5 voltage, when you turn on output pin low, you will turn it off. In the Arduino code, you have to configure each pin that you want to use as either input or output. When the pin in model 3, 4, 5, our output, 2 pin 2 inputs. When the pins are output, you can turn on components like LEDs output, like LEDs. If you set the pins as inputs, you can check if a switch is being pressed or not. 3, 4, 5 output. You can turn on components like LED, Breadboard. If you set the pin as input, pin module input, you can check it if a switch is being pressed or not.
Laushi, I didn't understand. Can you please repeat it again? The previous slide. Yes, Laushi, this one.
What? Okay. I didn't hear you.
Laushi, can you repeat it again? The pin mode 3 output. The pin mode 2 input. This one.
The output, you can stand up for the such as LED, LED ports output. Can see the output 3, 4, 5. you can connect the LED light port and the inputs input you can connect the button button 那个and the switch okay
OK，老师。
add 3 LEDs. Now let's set up our circuit. Let's connect this circuit. Okay, let's set up circuit. First, connect the 5 voltage to the on the Arduino. Connect the one of the ground pin on the Arduino to the back ground. And 3 LED. On the 2 red LED and 1 green LED. Okay. Green resistor. Okay, need to adjust the resistor. 220. And Oh. Need another register. Need to add a button. And care ohms. Then connect the owners. Okay. And five, 4, 3, 2. Connect to pin 5. Okay. Or info, the green LED connect to the page 3. And the push button connect to the pin 2. Okay.
Then
Let's see.
what's the use of this resistor? 10 kilo ohm. The resistor you used, yeah, down.
We can see I click the simulation, push the button, and no action. Anyone know what's the problem? Ask.
Maybe Laushi, we need to do the coding.
Start simulation and connect the button. There is no action. Okay.
Actually, there's no code, so there's no corresponding action.
Yes, you are right. Yes, you're right. Let's move on, and I will go to the letter. Okay. Okay. Simulation is not action. Some students said code is consistent with the circuit. That's right. So let's moving on, and I will get to that later. Okay. As the push button, you also need to add a 10 kilo-ohms resistance from the ground level to the button pin that connects to the button. We call this pull down resistor when the button is not pressed. The resistor pull pin 2 down to a value of 10 voltage. When the button is pressed, pin voltage is brought up to 5 voltage. Okay. Okay. The above simulation, the system does not have any reaction that is due to the simulation code and secured inconsistent. In this section, this part, we learn how to write the code that connects the button input to the LED outputs. Okay. The spaceship interface circuit should look a lot like a circuit that you corrected in the previous lesson. So let's get the code down right. Okay. The simulation code, and the circuit is inconsistent, so the system doesn't work, doesn't have any reaction. Let's code that. Okay. This is a C plus code. First, let me make the decision switch state 0, switch switch 0, and the word setup. The word setup is the setup routine learns when you place resist reset. Okay. Word setup. Initialize the digital pins at the. First, we need initial the digital pin as the output. 3 output, 2 red LED and 1 green LED. Okay. Three and 4. Okay, 3, 4, 5. We have 3 outputs. Okay, and we have one input push button, the pin 2, one input. Pin 2 is input. Okay. And the void loop. The loop routine runs over and over again forever. Okay, void loop. Loop routine runs over and over again forever. Switch. Okay. Switch state, switch state. The digital read digital read 2. Okay. Switch state digital read 2. If switch low, high or low based on whether the button is on or off. Okay. Now the no button is not pressed. Digital screen. Okay. Digital screen lights 4 and 5. Screen 5, 4, 5. Then green high and turn green LED on and the red LED off. Okay, low red LED off. Okay, else okay. Else Button, else button is plus, and button is plus. Okay. Delay. The track the LED, the red LED. Track the red LED. Delay. Okay. Button is plus. Okay. Button is not plus. Okay. Turn green LED on. Okay. Red LED. Red LED off. Okay. Track toggle. Tag the LED, red LED. Okay. Here is initial light. Digital in as output. Okay. Let's do the simulation again. What low with no degree is curve. Build power. Okay. Switch rate. Switch state was set up. Ring 452. Switch state. Switch to 2. Low. Digital lights high. Run. Switch. Oh. Low. Okay. We can see the green, the green light is light up. Okay, light up. Then when I correct part, red button, the red LED, red light is breaking. Okay. When we switch put the switch that's change to high, what happened? What? Okay, let's start simulation. We can see red LED is breaking. Okay. When press the button, the green lights will light up. Okay. Yes. So you can make use of the work plan, making some more modifications to the code, and check out what happened. Okay. So when we make simulation, the circuits should be consistent with the code, okay? And you can make more modifications to the code, make some track, okay? For example, you can change the LED to low. Let's simulation. Okay. Okay. Today's class stop here, and we continue next time. Okay.
Okay, Laushi.
You can try some simulation, some
Okay,
simulates.
Laushi.
Okay.
Thank you.
Okay. Next time we. Okay. Today's class stop here. Next time.
All
See
right.
you later. Okay.
Yes, sir. Yes, sir.
Laushi, is there any assignment for next class?
Okay. You can build in the circuit as the demo. Okay. Building the circuit as the demo, and making some modification to the code. Okay. You can build in the circuit as the demo. And made some modification in the code text, okay, and make some simulation. Okay, so the class stop here. Okay.
Okay, Laushi.
See you later. Next time. Okay.
Bye bye.
Okay.
Bye bye. Thank you.
Bye bye.
Bye bye.
Bye-bye.